part of this conference, which is a fire chat with Oscar Zhang from JinkoSolar. Oscar?
Yeah, I'm here. Yes. Can you hear me?
Can you switch on your camera?
Yeah. I'm actually in the car, if you don't mind. You see me well?
Okay, okay. Yeah, it's dark. We can't see so much.
Yeah, I
Okay.
mean, sitting in the car.
Okay, okay. Okay, then, I think we are also overboarded with time. So let's briefly talk, how, TOPCon is now more or less the state of the art. And, just would like to discuss from the pioneer of TOPCon segment. So, Jinko was the first major solar manufacturer to heavily invest in TOPCon. So tell us briefly about the developments about TOPCon at Jinko.
Okay, so yeah, in short, it's actually a long story because we started the development very early. In the R&D stage, we started pretty much around 2016. So we have the laboratory and we have everything ready for the all process flow. And during the time, we studied the process flow, and also all how to improve the efficiency and everything. And then the next stage will be the R&D pilot line. And then we started and we triggered a small production line for N-type. And then the next stage will be relatively large scale production. So it comes with step by step, development. So I would say it's a long story. Yeah.
But when did you feel it was really the right time, or when you feel it was ready for the mass production? So what really the decision making parameters?
Yeah. It's a good question. Actually, we feel it's ready is when we have finished pretty much when we started to do the production line with we used to have a 800 megawatt production line together with operation people. So and we started the line together and we do the improvement together. It's around 2020 about that time. So we conquered a lot of problems, especially the yield rate and also the production cost. So during the time we have together, the R&D people and also the operation people have great confidence on achieving a good cost for TOPCon. Well, the efficiency wise, there's no problem even at the beginning. So the cost is the overall evaluation for this technology. So when we have the confidence on the cost, then we know it's pretty much ready, and we will know it's gonna succeed in the large scale, because it's in a larger scale will be even cheaper in terms of the production cost. Yeah.
With like any new technology, at the beginning of the commercialization, there are always unforeseen issues. So can you reveal what was that? So what really surprised you the most when going through this path?
It reminds me of the for N-type solar cells, the O-ring problem, or so-called O-ring. Someone also call it concentric rings. So it's a new thing for N-type. So during the PERC stage, we don't have this. We normally have the dark center, but we don't have the O-ring. It's a new phenomenon on the EL testing. So that's pretty much the new thing for N-type. And then we realize it's actually a particular thing that correlates everything from the ingot growth to the cell and to the module. So that's really something we had a problem before. Yeah. And then
so,
I think
please.
Yeah, I mean, so when we have the large production, so when with R&D, we can choose the best wafer. We can even choose the average wafer with several bench, but eventually when we go through production line, at the certain stage, we cannot choose the wafer. We have to use all the wafers come from the furnace, come from the all the ingots. Then we realize there are a certain level of concentric rings, so which is not much, but still it's a big problem for the module side, because when you have 1% on the cell side, then you pretty much have like pretty much more than 20% on the module side. So it become a big issue. And then we started from the wafer level. We start from the ingot, like ingot cross to study what's caused the concentric ring, and then turns out to be a high temperature related problem, and also like it's highly related to the oxygen content in the wafer, which then come back to the wafer growth stage. Then, so that means like we need to reduce oxygen concentration in the wafer growth, and then we need to try to reduce the temperature we use during the cell level. So we need to do a lot of things to overcome this problem. Yeah, eventually. Yeah. Yeah.
Jinko is kind of a pioneer in the TOPCon section. So do you think it was worth to be pioneer? Because the followers usually have it very easier, right? If you are not the first one who is running this long mile, a lot of people learn from your mistakes also. So what's your thinking now?
Well, I think firstly, to enjoy the leading time is still quite a good thing, because of the the profits during the time you are the only one who can actually earn extra premium. So definitely it worth to being the leading innovation. However, it is true, it's actually a very practical thing that learning from others actually shorter the time that you started something. And also particular for new technologies comes all the time, and then but actually like developing the new technology is really a time consuming thing. However, I think like firstly, we still want to do the innovation, want to do the R&D, and I mean, like most of the time when we have the better understanding, it not only helps with the new technology implementation, but also help with optimizing the current products. So as you can see that even for now, we still have giving a very good solution for the whole production line compared to many newcomers, and we still have some experience. That all due to this, we have our basic and fundamental understanding, and which you call the pioneer development. I guess like it's still a good thing. We will continue to be to be the pioneers for many new technologies. But I have to say that like at this stage, TOPCon is the like mainstream technology. There are a lot of smart people in the market. a lot of people are working on the innovation. I guess we cannot be the leader for everything. So we're open for a more competitive world, and to learn from others, and trying to to make ourselves technology become better and better. Yeah.
So give it a chance. Would you do it again?
Yeah, for sure. I think we are doing all the time, even for now. We're trying to testing a lot of new structures, new technologies, and which everything I like every technology. I think all of them can make a change for the industry. However, as technology goes ahead, maybe some of them become better, and then that's a natural way. So we will always try. So, and also the R&D people enjoy developing new stuff and trying new challenges. So yeah, so I think the company is very supportive on developing new technologies and trying to be the leaders for all the the pioneer technology. So yeah, so we definitely want to do that again, and we're actually trying to do that.
So, Jimco has always been at the forefront in terms of record cell efficiencies for many years. So, how important are efficiency records?
It's a very good question. Actually, internally, we consider the laboratory record is more like a guideline. So we don't on purposely do laboratory kind of stuff, but because everything we do, we have a basic analysis and basic plan that even though we do it in a laboratory in a small scale, but eventually one day it is possible to do in the production line. If something we don't see is possible in the future, then we probably won't give a very high evaluation for the technology. So for the high efficiency project and high efficiency cell team, we always want them to try everything they think might be making a change, and eventually, as I mentioned during my talk, we have tried summarize all the previous technology we tried before. Things developed during the laboratory eventually will become a part of the production. Maybe some of them are not actually in the production line, but it's replaced by something better. So it's a good guideline that we will go that way. And also since we can achieve something in the laboratory, we have the confidence that eventually we can make every cell become that level. So it's a very good guideline and also a very good test of trying something very different. Because if some technology we cannot really achieve in a laboratory condition, there's probably very low possibility in the production. So it's also it's more like a filter for production technology. Yeah.
So, the theoretical efficiency one thing, but the practical limit is another thing, right? So, when do you think you will hit the practical limit for the TOPCon, and where is this practical limit for TOPCon?
Yeah, actually, I mentioned a little bit during my talk that the theoretical limit is very high, but there are also some practical simulations done by us and also done by other researchers, and there's published papers saying that something about around 27.5 is highly possible. So we have simulations for this idea, and also we have more practical settings and boundary scenarios for this. So I think like above 27 is quite possible. 27 is a bit challenging for the current model, but things are changing very fast. New technology may bring different ideas, and previously we think that genome metal cannot be like a below 30, but some technology has already showed the potential. So I would say the model also will change accordingly. So for now, we are quite confident above 27 is possible. We will try our best to achieve 27.5, and close to 28 may be quite challenging for now. But I won't say impossible. I would say it's challenging. Yeah. Yeah.
So down the line, 2 to 3 years, we can see this.
Hopefully, hopefully. Yeah.
Fingers crossed. Okay.
Yeah.
So then, do you think TOPCon might rule longer than expected? As we have seen with the PERC. So where do you see the lifespan for the TOPCon?
I think it's a very difficult question. I can't give a very accurate answer for this, but I would say things are quite different compared to the time that we are switching from BSF to PERC structure, because there aren't many options during that time. And also the development during PERC stage is quick, but you can see obviously the technology innovation during PERC stage is not as quick as during the TOPCon stage. We see a lot of new technologies. When we come into the TOPCon era, we see the high shear resist technology. We see the slack emitter. We see the new novel metallization, a lot of new technology. So actually things are getting accelerated, the development of new technologies. So ideally, we might see a big change. The big change may also like shorten the time that we reach certain target. However, the big thing or the optimistic thing for TOPCon is the high level of the optimistic goal for TOPCon is much higher. For PERC, we know there is certain level that's already very challenging for PERC, so the gap is not that big. But for TOPCon, the gap is very, it could be very big. So if we can see that very high efficiency to be possible for TOPCon, so that means like the possibility for further going forward is also big. So I would say it's hard to say, but at least we already have TOPCon in the market for 2 years, so it's already becoming a very good product. For PERC, we might see it in for example around 4-5 years, but for TOPCon during the past 2 years already very big, but very quick, and the further going down, further 2 years and further 3 years is very likely. So I would say it might be very similar to PERC, but we will see how new technology or new innovation can bring us. Yeah.
Okay. So, now that everyone has started following TOPCon and TOPCon is kind of established, so what's next for Jinko? You showed in your presentation, perovskite tandem. So will you jump directly? Is this your actual plan, or will there be any intermediate step?
I think even
like
for even for the single junction era, single junction stage, there's still a lot of things to go. For the current step forward, the standard TOPCon structure, we only have one side that being piezoelectric for the metal region, and for the front side, there's still room for further improvement in terms of the metal region piezoelectric contact. So there's a big room for this, and also even for BC, it's using like a double piezoelectric contact region as well. So it's probably very similar as the updated TOPCon. So it just when we use the piezoelectric contact, whether it's on both sides or it's on only one side. So, but eventually, fundamentally, the material and also the technology are very similar. So I will see that the material will improve. So we will see that further improvement for TOPCon will be like leading the mainstream technology growth, such as double side piezoelectric contact and some novel metallization technology. And also in terms of optical improvement, we actually see a lot of possibility for the current market. Yet, that's making both the front side and back side more optically improved is highly possible for next year. So there's still room for improvement for next year and the year after. In the future, we see that we eventually, when we reach something like 27, 28, it is true that we need something more evolutionary, more like a tandem is becoming a hot topic and becoming a realistic analysis topic. So you know that we are developing technologies in the tandem approach. We are doing tandem based on TOPCon, and we're also doing the material study on the tandem basic structure. There's a lot of things to be developed for the layers of the perovskite and also for the interlayer and also for the TOPCon. So I would say for the future, we believe that this approach, this high temperature piezoelectric contact approach, can lead us a very long way. And efficiency will go up and up. However, the products wise, you will see a lot of new changes in the ideas of product developing, such as particular design for different areas, for Middle East areas, for like humid areas. So there's a lot of possibilities and new technologies. So yeah, I think it will be a very fruitful world for PV technology in the future. Yeah.
Hoping for the best. So thanks a lot
Yeah. Thank you.
for your great insights.
Yeah. My pleasure. Yeah.
Thank you. Okay, so now we come to the end of this day one conference of TaiyangNews High Efficiency Solar Technologies. Okay, so as Michael mentioned in the morning, like the biggest differentiation with TaiyangNews is, in addition to these free virtual conferences, which are very informative, in-depth in technology, we also publish reports on various techno-commercial aspects of PV production, be it cell technologies, module developments, and recently we have also started looking at the finished module products, and also at system level like trackers and floating PV. So here what you can see is these are all the reports that are available for free to download, and soon we'll be coming out with a report on bifacial technology and floating PV technology. Next slide. So yeah, today we have talked about TOPCon, and tomorrow is the day for the heterojunction. So we have, like today, we have also carefully built the conference where we are trying to put several stakeholders in this section of PV to share their results and their views on heterojunction technology. So we have a keynote from Christoph Balif, and then we have presentations from Huasen, Ryzen, and then we have a paste maker like Fusion speaking on the heterojunction paste development. And we have Maxwell, who is a production equipment maker, and again, Cybrid talking on the encapsulation side. Then we have your buddy who would also speak on materials, the ribbons for the 0BB, which is right now hot topic in the heterojunction. And we have another heterojunction speaker. He is speaking at our conference tomorrow. Next slide. And finally, like today, we will also close the session with a fire chat with Kenny Ding, head of R&D at Forschungszentrum Jülich, just to reflect a little bit on, when the time would come for heterojunction. So next slide. And once again, thanks a lot for to our sponsors, with the help of whom we were able to make all our events for free. And thank you very much, every participant and all presenters. Thank you for joining us, and we are really looking forward to seeing you tomorrow at the same time. Thank you. Have a nice evening. Bye-bye.